Okay, for section 7.3, we're going to be discussing solving linear systems of equations. So before we start that, the definition of a system of linear equations is just a set of two linear equations. Okay? There could also be three linear equations or four, etc. We're going to focus on just systems of two linear equations for this class. And ultimately what we're going to be after here is finding the solution to a system of two linear equations is an ordered pair, notice, that satisfies both equations in the system. So when we get finished, we're going to have some kind of ordered pair, like say the point 5, 2, and if we plug in 5 for x and 2 for y into both equations, and we get two true sentences, then we have found the solution to the equation. Okay, so let's look at a couple of methods that we're going to use here. First of all, part of our work, we're going to just determine whether or not an ordered pair is a solution to the system. So they gave us a system of two equations here. Notice that both of these are linear equations in standard form. And so our job here at this point would be to put in 1 and 2 and decide if we get a couple of true sentences here. Now keep in mind that in order to be the solution, it has to be the solution to both, not just one. Okay? So if we replace 1 and 2 with the x and y's here, etc., and we can see that on the left-hand side, if we put in 1 and 2, it turns out to be -4 equals -4, which is true. And on the right-hand side, if we put in 1 and 2 also, we get 2 plus 2, which is 4. So again, question mark, are these true? They are both true, in fact. So therefore, we would say yes, that 1, 2 satisfies both of the equations, and therefore it is a solution of this system. Okay. Now, if we don't know the solution and we have to find it, there's three methods that we're going to use to do so, and one is going to be graphing. Okay? And ultimately, when we graph two linear equations, unless they're parallel to each other, they're going to intersect. And if they do intersect, then that intersection point is the solution to the system. So as it says here on the slide, for a system with one solution, the coordinates of the point of intersection of the lines is the system solution. Okay? So hence, if we were asked to graph these two lines, they're both in standard form. So however you decide to graph them, you could solve for y here and use the slope and the y-intercept, or you could find the x and y-intercepts and graph them that way. Either way, if you do it the intercept way, which is the way that I would recommend, okay, we can see that for this particular one, we get a x-intercept of 2, 0, a y-intercept of 0, 1. So we'll graph that one. Okay. Along with the other one, if we put 0 in for x and solve for y, we get 6, 0. If we put 0 in for x and solve for y, we get 0, -3. So of course we can plot those 2 points, draw our graph, and when we do so on graph paper, and in order to get the solution, we need to do this on graph paper, draw it very carefully. Okay. And we can see that the first line is this one, okay. Second line being this one, and we can see where they intersect here at the point 4, -1. And that 4, -1 is going to be our solution to the system. Now, of course, if our claim by graphing is that this is the solution, we should certainly check that by doing what we did in the first example, where we plug 4, -1 into the two equations and make sure they both give us true sentences. Because if they don't, then maybe we have a mistake here in our graph. Okay? Now, the next type of method that we can use, because graphing is nice, but graphing generally is only good as long as we have a whole number set of points, because if we don't, if those were to intersect somewhere in between whole numbers, it'd be very difficult to tell what the exact answer is, because we would have to estimate what it would be with a fraction or a decimal, which ultimately may or may not give us the right answer. So we have some other methods that we're going to use so we can find exact answers, because again, sometimes they don't fall on nice numbers like 4, -1 in the previous problem. Okay, so we're going to use this idea called substitution. Okay, this is going to be one of our methods. And in the following steps here, if you follow these steps exactly the way they're written, okay, then we should be able to find the solution to the given system. So, number one is to solve either of the equations for one variable in terms of the other. If one of the equations is already in this form, then you can skip this step. So we generally want to use this if one of the equations has a variable alone already. If it does, then we're already ready to go. And if it is, then what number 2 says is we're going to substitute the expression found in step 1 into the other equation. This will result in an equation with one variable. Then we're going to solve that equation for the one variable, and then we're going to take that variable and substitute it back into the previous, or to one of the originals to find the other variable, and then we're going to check by taking x and y and plugging them into both and making sure they both work. So let's see that in action. So this set of steps is in your book. You can follow very carefully as you work. So this particular one, we have y equals negative x minus 1, and then we have one that's in standard form here. So we do have a variable alone already in one of the equations, which is good. Okay, so what we're going to do then is this. We're going to take that stuff that y is equal to, because y is equal to this stuff, and we're going to replace the y in the other equation with that stuff. So we're going to replace this y with the quantity negative x minus 1. Okay. Now, as illustrated on this next slide, again, just like I showed you, we're going to take this stuff and we're going to put it in for y. We're going to substitute it. That's why it's called substitution. And we're going to put that into the other equation. And notice when I took that expression and replaced y with it, it's in parentheses. If you do not use parentheses, pretty good chance you're going to get this wrong. So make sure when you're substituting something into another sentence that you're putting it in parentheses. Alright, and you'll notice that the variable y is gone. We have a variable x here, so at this point we're going to simplify and solve that linear equation. Okay. So on the next slide they did that. They distributed here, of course, plus 3 and then plus 3x and plus 3. Combine the like terms and subtract and divide, and we get x equals 3. Okay. So that's the step 3 part. Step 4, we're going to take our x equals 3, because remember we're looking for an ordered pair here. If we just find x and quit, then we're only halfway done. So we're going to need to take the 3, plug it back into one of the two equations that we started with. Okay, preferably the one that you didn't use here to do this part. Okay, so I plug it into the other one, and that's exactly what they did on the next slide. They put the 3 in here, so negative 3 minus 1 is negative 4. So our proposed solution is 3, negative 4. Now again, you can go ahead and move on to the next problem if you want to, but if you want to make sure you're right, just like any equation solving process, we can plug this back into the original equations and make sure they work. Now, in terms of the check part, if you put a 3 into this, you're just going to get the same thing you got back. Okay, unless you made a mistake, hopefully you didn't. So really what you want to do is plug this into the other equation, the one that you didn't use to find the other variable. And if you take a look at this into the original, you would find that we do get a true sentence, and therefore we could go ahead and circle that and be done. Okay.